Air quality and emissions assessment. Air monitoring is performed to measure air quality for many reasons, including to assess emissions compliance to the National Ambient Air Quality Standards. The 7 criteria pollutants are measured at many monitoring stations across the country. Those areas where criteria pollutants exceed limits are typically monitored more heavily than areas are within attainment, that is, compliance with the regulations. Information on the concentration of criteria pollutants and if an area is compliant with the requirements can be obtained through the Air Quality Index, AQI, as we discussed in week 2. Monitoring also provides information on long-term trends. It can be used to estimate human exposures. It can provide data to where pollutant reduction efforts should take place. And finally, it can be used to assess the effectiveness of emissions reduction programs. While air monitors are often located near ground level, there are also monitoring conducted by satellites and other space vehicles. Space-based monitoring can complement and enhance ground-based monitoring systems. It was NASA's total ozone mapping spectrometers and their ozone monitoring instrument that detected the drop in stratospheric ozone in the early and middle 1980s. Pollutants are collected on a media. It may be a liquid or solid media depending on the pollutant. Grab samples are those of short duration. They can measure most pollutants. They are often used in situations where there may be a problem, where immediate results are desired, such as a spill or during a heavy discharge event. A grab sample provides a snapshot for a discrete period of time. On the other hand, continuous samples collect samples over a long period of time. Air is drawn through a device at a specified rate. This allows for a detailed analysis where concentration of the pollutants over a period of time can be expressed. Most of the limits placed on environmental emissions are based on not exceeding a certain concentration over a specified period of time. Regardless of what collection method is used, it is critical that the sample represent the amount of pollutant under investigation. The sample obtained must be a subset of the overall emission source. That is, it must be representative of the emissions. Sampling is similar to polling. In polling, if you do not interview a representative cross-section of the population, the chances are your results and predictions will be inaccurate. To be representatives, there are 3 important concepts to consider: accuracy, precision, and bias. Accuracy is how close the measured value is to the true value. 100% accuracy should always be the goal, but in reality, it is something less. Accuracy can be determined by analyzing a known substance, a standard, and comparing the actual results to the expected results. If the obtained results compared to the standard are within 98% of the true value, you can say with confidence that your results are 98% accurate. Typically, a standard or reference is run with the samples and offered as part of the overall results. These results, along with the reference standard measurements, should be supplied to those requesting the sample and analysis as a quality control measure and provide confidence to the customer that your results are correct. Precision is how repeatable a result is. That is, how often do you obtain the same or very similar relative result. One can be precise, obtain the same or near same results again and again, but if it is not accurate, there is still a flaw in your system. Finally, bias comes into play when there is a systemic error that causes errors in maintaining the true value. These errors may be due to calibration errors or issue with the hardware to conduct the analysis.